Hello everyone, welcome to the Makri Virtual. Hope you are doing good. Today I'm going to continue with the same module, that is the procedural programming module. In the last class we have started with, or we have covered few topics of the chapter number 17, that is C under the Windows. Now I'm going to continue with the same chapter, that is the C under Windows, that is how to execute the C program under Windows programming. Right, so this is the chapter. So let's start with the last class session. That's a quick review of the last class, what we have covered in the last class. In the last class, we have covered some theoretical part of this chapter as well as the practical approach for displaying or for using the while loop. That is how to use the while loop, how to execute the while loop, why it is advantageous to use the while loop, and what is the factorial of or how to find out the factorial of a number. So let's start with the last class session. In the last class we have started with the Windows concept, that is the more Windows. Sorry. We have covered about the program that is covered or that is taken into the Windows, that is the more Windows. This is now that or till now we know how to create a window, but now let us see how to create several windows on the screen. So we have shown the I've shown the program, that is how to create the multiple windows on the screen. This is the header file. First one is the header file. Then this is the function arguments and the function. The function name is winmain, and int std call is the standard that is used, that is of integer type, and these are the various arguments that is used in this one. And this is the array variable. This is int x. This is the for loop that we have covered, that is it will execute for the 10 times, that start with 0 ending with the 9, that is 0 1 2 3 4 5 6 7 8 9. This create window is used only for creating the window, not for displaying the on the screen. But when I want to display on the screen, that is done by the show window function. So there are different functions. One is create window function, one is show window function. This specifies that I am going to create either list box, either edit menu, either button. In this there is only a button. This is OK button. That's why I am using the button. Then there is a press me. This is the keyword that is to be represented. This is press me. Then WS overlapped window. This means the window that multiple window that appears on the screen are overlapped with each other. Overlapped means combined with each other and one over the another, that is overlapped. Then these are the various dimensions, that is x into 20, 20, 150, 100, 0, 0, I, 0. So these are the various dimensions, and this last one is the pointer to the function. So these are the various arguments that we discussed, that what are the arguments, what is the meaning of each argument, what are the measurement, or what is the measurement unit, that is either in pixel or either in percentage. Then next one is a show window, that is also contain the array elements. Then this is the message box that is used to display on the screen. So this is the message box, 0, high, waiting, 0. So these are the four arguments that is used. The first one is a 0, then there is a keyword or there is a text that is appears on the screen, that appears on the menu, that is a high, then there is a waiting, then there is a 0. So these are the window that appears like this. There is a return 0. Why there is a return 0? Because we have used the int. So whenever we use the int, till now we use void main, right? So there is no requirement for returning the 0. But if I'm using int main, why? Because int takes 2 bytes in the memory. So it's mandatory to use the return 0 in case of int main. As in normal programming that we have we are showing right now, that is a few examples. In that examples we covered, or I covered only void main. So there is no requirement for the return 0. But if I use int main, so there is a requirement for the return 0 in this. This says, note that each window created in the program is assigned a different handle. You can experiment a bit by changing the name of the window class to the edit. As I told you that you can change the name of this one, like either button, either list box, either edit. You can change it according to your requirement. Next is a real world window, that is how to use the real world window, that is how to create the window. That is, there is no standard window that is available, but you can choose the window requirement, you can choose the window interface layout as per your requirement on the basis of the requirement of the user. So this is another program that shows how we are using the windows. There is a on destroy function that is used, that is the user requirement, that user needs the on destroy function. This is the helper.h, this is also header file. Then these are the various arguments of the main function, Windows main function. These are the various parameters. One variable is declared, that is m, that is of message type. This is the application initialization, that is how to initialize, that is done by the init instance. There is a message loop, this is a message loop by using the while function. Then there is a return 0. Why return 0? Because it is using the int main. This is int main or int main, that is the same concept. So in case of int, we have to use the return 0 over here. Then this is the next one, that is L result callback WND proc. This is the next one that is used for the result. These are the 4 arguments that is used. Then there is a switch case we are using, that is switch message. What is the case? That is if it is WM destroy, then call the function. So this is the function calling we have covered in the last class, and this is the definition of this function. So whenever a cursor moves to this one, automatically the cursor moves to this part. This is simply post quit message 0, that is quitting the message, that is a post quit message. Otherwise, if this is not issued, that is there is no case of destroy, then return default window program proc. These are the 4 arguments, that is w param, I param. This says on execution of this program, a window shown in 17.4. So this appears like this one whenever we use this programming, whenever we execute this code. Now then we have discussed how to create and display of window, that is in step by step. So this is the most important part. There are 4 steps for creating as well as the displaying the window. First of all, create a new window. Then register the window with the operating system, that is simply interact or merge with the operating system. Tell the operating system that I have created the window. Then creation of a window based on the registered class, that is we have registered with the OS, that is window has registered with the OS. So now it's a time to creation of a window that is based on the registered class. Then displaying the window on the screen, that is next part is displaying the window on the screen. So these are the 4 parts. One is creation, one is registration, one is creation of a window based on the registered class, one is displaying the window on the screen. Next point says creation of a window class involves setting up the elements of the structure that is known as WND class X. So this is the window class, that is X. So this is the most important part. This contains various API functions like this one, create window, show window, that we have covered, register class X, init instant, that is all functions are available in header file that is known as the helper.h. This is the link that we have discussed, that you can take out what is available in the helper.h or what are the library functions that is available in helper.h. Now this says once the window has been created and displayed, let us see how we can interact with the window. That is, let us see right now how to interact with the window. Or till now we have covered only creation and display. Now it's a time to make the window dynamic. Dynamic means interact with the window. Suppose I press OK, then where is the cursor moves or where is the input goes, that is the interaction with the window. So let's start with the today's session, that is the interaction with the windows. This says as and when the user interacts with the window by stretching its boundary or clicking the buttons in its title bar etc, a suitable message is posted on the into the message queue of our application. That is, whenever we interact with the windows or whenever we make any changes or any modification in the window, either we can click on the title bar, either we can stretch with the boundaries, either we can make the or rotate the scroll bar, vertical bar. That is means any effect on the window, then suitable message, that is suitable on the basis of the that if I choose the title bar, then a suitable message is posted on the message queue of the application, right? So our application should now pick them up from the message queue and process them. So our application now pick up that one and pick them from the message queue and process them. That is the interaction with the window. That is, first of all, we can use any operation, that is either clicking with the button, either clicking with the mouse. Then a suitable message is posted on the message queue of our application. It is the application that picks up that message from the queue and process them. So there is a indirect communication with the message queue and the application. Now, a message contains a message body. That is, whatever the message is sent or pick up or is gone into the message queue, then a unique message ID is generated and some other additional information about the message. For example, a mouse click message would contain additional information like handle to the window with which the user has interacted. That is, a mouse click, we click on with the mouse, that contains additional information like handle to the window with which the user has interacted, the coordinate of the mouse cursor and the status of the mouse buttons. Like these are the various operations, that is how we can get the additional information about the message. Yeah, this is the most important line, since it is difficult to memorize the message IDs, because that is a unique ID, that is either alphanumeric, text, characters or numbers. It is very difficult to memorize or remember the message ID. So they have been suitably hash defined in windows.h. So that IDs are already defined in the windows.h. The message ID and the additional information are stored in a structure that is known as the MSG. So all the information about the message ID, what is the role and what is the usage of message ID, what is the shortcut key for message ID, that all the information is available in the structure that is known as the MSG. So MSG is like a type def that we have covered. Type def means like a keyword that is used with the variables. Next point says, in WinMain, this message structure is retrieved from the message queue. That is, this message structure, that is the MSG structure, is retrieved from the message queue by calling the API function. So in case of WinMain function, that is the main entry gate, the MSG structure is retrieved from the message queue by calling the API function. Which API function? That is the getMessage function. The first parameter passed to this function is the address of the MSG structure variable. So the first parameter that is passed is the argument, is the variable, is the address of the message structure variable. So there is one more function that is called, that is the getMessage function. So the first argument that is passed with this one, that is under the parenthesis or inside the parenthesis, that is the MSG structure variable. Now getMessage would pick the message info from the message queue and place it in the structure variable passed to it. Don't bother about the other parameters right now. That is, what are the other parameters under the getMessage? So don't bother right now. So next point says after picking up the message from the message queue, we need to process them. So till now we are getting the message from the message queue. So first of all, a message will be entered in the message queue. Now get message by using the MSG, pick up the message. Now after picking up the message from the message queue, we need to process it. We need to process the message. That can be done, or this can be done by calling the dispatch message function. So first of all, get message function that is used to pick up the message. Next one is dispatch message function that is used to pick the message, or sorry, not picking the message, that is done by the create message, but it is used for process the message, that is a dispatch message function. API function, this is also a API function, that is a dispatch message. This function does several activities, that is this function is very important and do the several activities that is available, that is the next function that is available over here. So what are the various activities that is available under the dispatch message function? The first one point says, or what are the activities? The first point says that there are, or from the MSG structure we that we pass to it, that is the MSG display message function extracts the handle of the window for which this message is meant for. That is, whenever we use the MSG structure, then we have to pass, or we pass to it display message that extracts the handle of the window for which the message is meant for. From the handle, it figure out the window class based on which the window has been created. That is, first of all, use the MSG structure that we passed with the display message, then extract the handle of, or that extracts the handle of the window for which the message is meant for. That is, first of all, use the MSG structure. Then from the handle, it figure out the window class based on which the window has been created. That is, whenever we handle, or when we handle the MSG structure, or from the handle, it figure out, it takes out the window class based on which the window has been created. Next point says, from the window class structure, it obtains the address of a function that is known as WND-proc. That is, the next point is, or the next part is, that is, when we use the window class structure, it obtains the address of the function. It obtains the address of a function that is known as the WND-proc function, that is short for, or that is full form is Windows Procedure. Well, I didn't tell you earlier that in init instance, while filling the WND class X structure, one of the elements has been set up with the address of a user-defined function, that is WND-proc. So WND-proc is used to getting the, or obtain the address of the function that is known as WND-proc, that is a Windows procedure. Using this address, it calls the function that is a WND-proc. So these are the 4 points, these are the various activities that is available with the dispatch message function. So first of all, MSG or MSG structure is used, then figure out or class based activities, then WND-proc, that is a window procedure is used, and then use the address, it calls the WND procedure. This whole procedure is controlled by the WND class X. Next point says, since several messages get posted into the message queue, picking of the message and processing it should be done repeatedly. That is, the processing or the retrieving the messages and process, that is, first of all pick up the message, then process the message, that all can be done in a repetitive basis, that is in a loop control. Hence, calling to the get message and dispatch message function have been made in a while loop in winMain function. That is, therefore, calling to the get message and dispatch message has been made in a while loop in the winMain function. When get message function encounters a message with ID wm_quit, so whenever message comes that is a wm_quit, that returns a 0 value at every time. Now the control comes out of the loop and win main comes to an end. So whenever we have to quit from the message after processing, then we use the or then get message encounters a message ID, that is a WM quit, that returns a 0. Now next part is reacting to messages. Till now we covered how to interact with the messages. Now the next part is how to react with the message. This is, as we saw in the previous section, for every message picked up from the message queue, whenever that is we have shown that when we picked up the message from the message queue, the control is transferred to the WND procedure, that is the window procedure function. That is whenever we pick up the message, that is whenever we interact with the message, the next part or the control is transferred to the window procedure, that is a WND procedure function. That can be shown by using the function, or this function is shown below, that is a window procedure. So this is first one is L result callback WND procedure, that is a proc, that is a window procedure. Now there are various arguments that is used. One is HWND, uint message, wparam, lparam, lparam. So this is how we can react with the message. Now this function always receives 4 parameters. What are the 4 parameters? One is HWND, then uint message, then wparam, lparam. The first parameter is the handle to the window for which the message has been received. That is how to handle the window. That is the first parameter. The second parameter is your ID. That is a unique ID for the message. That is a message ID. Whereas third and fourth parameter contains additional information about the message. So this function contains, window procedure contains 4 parameters. One is how to handle the window. One is message ID. Next 2 parameters are the additional information about the message. So these are the 4 parameters. These are the 4 arguments that is used with the window procedure, that is WND proc. Now next point says L result is a type def of long int. So this L result, this one is a type def, that is like a keyword of a long int. That is whenever we use the long int, it is using the L result and represents the return value of this function. That is a return value of the WND proc. So this is the L result, that is of long int. This is L means long, result is a type def. Then next is your callback. It is a type def of std call. So we use the std call with the win main. So it is just like a int std call. It is a callback, or it is a type def of the std call. So this is just another name of the std call. This type def have been done in Windows.h. That is this type def has been covered in the Windows.h. Then callback indicates that the WND proc function has been registered with Windows through WND class X structure in init instance. That is callback indicates, or it identifies that the WND proc function has been registered with the Windows through the WND class X structure in init instance. That is window procedure function has been registered with the Windows, with an intention that Windows would call this back through dispatch message function. So every activity of the window procedure is registered with the WND class X. That is the main class that is used, that is the window class X. That is done through the dispatch message function. Next point says in WND proc function we have checked the message ID using a switch. So whenever we use the window ND WND proc function, this function, or we have used this function to check the message ID using a switch case, as I told you. So there is a switch message, and when it is wm destroy, then we call the function, otherwise we can return back to the close window. So this says in the window procedure we have checked the message ID using the switch case function. If the ID is wm destroy, like this one that we have covered in the yesterday's class, this is the function. This is this part. There is a switch message, so it deals with react with the message, that is how to react with the message. This is a switch statement. There is one case, that is wm destroy. If it is the case that is wm destroy, then use this one, otherwise that is default, return this one. So let's see. So this is, if the ID is wm destroy, then we have called the function on destroy. We called the function on destroy. This message is posted to the message queue when the user click on the close button. That is, whenever user click on the close button or close window button in the title bar. So this is used, or this message is posted to the message queue when we click on the close button, like this one. This is the window. When we click on this close button, then only this destroy function is used. That is, whenever we click on the, or user click on the close button, then this will fire, or this will execute, and this is the definition of this function, right? So this message is posted to the message queue when the user click on the close button in the title bar. In on destroy function, so this is the function, we have called the API function, that is the post quit message function. So this is the message function, this is the API function, that is the application programming interface function, that is a post quit message function. This function posts a wm quit message into the message queue. So whenever a destroy function is used, that means simply vanish the function, destroy the function. So a new API function is used, that is known as the post quit message function. This function posts a wm quit message into the message queue. So this uses this post wm quit message. This is another message that is used, and this message is posted into the message queue. As we saw earlier, when this message is picked up the message loop, and win main is terminated. So whenever we use the wm quit, as we saw in the last section, whenever this message is shown up or picked up, the message loop and win main function is terminated. That is, this will be changed, or that will be terminated. That is the win main function. For all the messages other than the wm destroy, the control lands in the default close of the switch. So if there is a wm, or if there is an on destroy function, this is called, this is okay, then this function is called, and the win main function is terminated. But if this is not the case, in on destroy is not the case, then use the wm destroy, the control lands in the default close of the switch. Then the control transfer to the default part of the switch. Here we have simply made a call to diff window proc API function, that is a default Windows procedure. This function does the default processing of the message that we have decided not to tackle. This default processing for different messages would be different. That is, the default processing that is done for the different messages would be different. That is the default message. For example, on double clicking the title bar, that is def window proc maximize the window. This is an example. That is, whenever we double click on the title bar, a new function is hired, or new function is approached, or new function is calling, that is a def window proc that maximize the window. So this is the next step, that how to maximize the function. Actually speaking, when we close a window, a wm close message is posted into the message queue. So there are various functions that is used for window operation, that is whenever we close the function, whenever we operate the function, different operations, different functions are used. So whenever we close the window, a WM close message is posted into the message queue. Since we have not handled this message, the def window proc function gets called to tackle the message. And the def window proc function destroys the window and places a WM destroy function message in the message queue. As discussed earlier, in WND proc we have made the provision to terminate the application on encountering WM destroy. That brings us to the long explanation. So this is the end of the long explanation, that what is the use of WM destroy, what is the use of window procedure, WM destroy. You can now have a size of relief. I would urge you to go through the above explanation till the time you are absolutely sure that you have understand every detail of it. So this is the long explanation. A very clear understanding of it would help you to make a good window programmer. So if you have a good knowledge, theoretical knowledge, thorough knowledge generally, then you have a good, or you are able to get the, or you are going to make a good window programmer. For your convenience, I have given a flow chart for the entire working, so that your concepts are clear. This flow chart is given. Wow, this is so nice. Why? Because if this flow chart is not available, it is very difficult for you to remember or to understand the concepts. So first of all, what is a flow chart? So I'm just coming within 2 minutes. Now let's take a flow chart, that is how flow chart is used. That is the next part. So first of all, it started with the oval. This is the oval, that is the start execution, that is the first part. And so in flowchart, the starting point is always represented by a oval shape. So this is in oval, that is the first part, that is the start execution. Then there is the next part, that is the next rectangle is used, that is a call init instant. So next part is calling the init instant, that is the initialization of the instance, that is the first part. Then uses fill WND class X structure to define window class. So first of all, start the execution, then calling the function or call the function, that is the init instance, then fill window ND, that is a WND class X structure to define the window class. Then fill out the window class X structure, uses the window class X structure to define the window class. So that is the next part, that is filling the window class X function. Then call the register, that is calling the register, that is a call EX function to register the window class with the operating system. So first part is start the execution, then init instance, then fill the window class X structure, then calling the register call EX function to register the window class. Then calling the create window to create the window in memory. That is calling the next part, that is a create window function to create the window in the memory. That is the next part, that is how to create the window, that is done by the create window button. So these are the 4 steps. I am repeating again. First of all, start the execution, then calling the init instance, then fill the Windows class X, then calling the register call X function so that it will be registered with the OS. The same steps that we follow, or there are 4 steps. First of all, creating the window, then register with the window, then create the window in the memory. All these the same concept. So then call the create window to create window in memory. So first of all, register in the memory, then uses the create window function to create the window in the memory. Then next part is call the show function or show window to display window on the screen. So first of all, fill the window class X, then register or call the register call X to register with the operating system, then create the window, then show window. Then pick out the message from the message queue minus that is done by the get message function. So after showing the window, now come next part comes to the interaction with the window or reacting with the window. So these four steps are simply used to create a window and display the window. This step is used to interact with the window, and this step is used to react with the messages, or reacting with the messages. This is interaction with the window, this is reacting with the messages, and these four parts are used for creating and displaying the window. This is this is creating the window, this is used for showing the window. This is again the arrow. There is a pick message from the message queue, that is picking out the message from the message queue, that is done by the get message function. Now this is used for interacting with the window. Now next part is reacting with the messages, that is how to react with the messages, what are the various options, what are the suitable options that is used while reacting with the messages. So this is the diamond box, this is known as the diamond box. In this we have to check the condition. So whenever there is a condition we have to check in this. Whenever there is a start we have to use the oval shape, and whenever there is some processing, there is some displaying, that can be done by the rectangle box. These are the rectangle boxes and this is a diamond box, right? Then check if the message WM quit, that is check the or reacting with the messages, that check whether the WM quit is higher or WM quit is used. If it is used, that is a yes, then simply stop the execution, that is also represented by the oval shape. So remember, start and stop is always represented by the oval shape. So if the message is message used is WM quit, that is quitting the window, then if it is yes, then simply stop the execution. If it is no, then process the message. If it is not quitting at this stage, then simply process the message, that is done by the dispatch message function. So for quitting it is using the dispatch message function. Then call the Windows procedure, that is calling the window procedure. Then next function, or if it is not quitting, then dispatch function is used. Then call the window procedure, that is wnproc. Then again uses the diamond box for checking the condition. Is the message WM destroy? Then it is also used for the WM destroy, that is either using the WM destroy. If it is yes, destroy the function, then simply, if it is yes, then simply process the or post the WM quit function, that is post quit message function is calling or called. That is the next part. Then if it is no, that is destroy function is not used, do the default processing of the message, that is def window proc. This is the WM destroy function that we have shown with the help of the switch case. If it is yes, then simply post quit message is used. If it is no, then simply default processing is done, that is a default case, right? If it is no, this cursor will move to the, this is the arrow, this cursor will move to this one and this will move to this one. That means again processing is done for the get message queue, that is the retrieving or interacting with the window. That is the next part. So this is the easy explanation with the help of the flowchart, that is how to handle or how to deal with the Windows programming, right? So I'm repeating again. First of all, start the execution, that is represented by the oval. Then we use various functions like init instance, fill window class X structure to define the window class. Then use the register call X function to register with the operating system. Then call the create window function for creating the window in the memory. Then uses the show window function to display on the or display window on the screen. Then pick out the message, that is retrieving the messages, that is run by the get message function. Then check the condition. If it is quit, that is the if the message or the function that is used is WM quit. If it is yes, then simply stop the messages, otherwise calling the dispatch message function. then call the window procedure by using the dispatch message function. Then if it is, again check the condition. If it is destroy, that is a WM destroy, then simply post WM quit, that is using the post quit message function. Otherwise, if it is no, that is WM destroy is no, then do the default processing of the message, that is a def window proc. So this is the flow chart. First of all, there is a starting phase, then there is various steps for creating the window, registering the window and displaying the window, and the next step is interacting with the window, and the next step is reacting with the messages that is available in the window procedure. Next part is your next term or next topic is your program instances. That is, what is the program instances? This is Windows allows you to run more than one copy of a program at a time. So it is also possible in the Windows programming that more than one copy of the program is executing at the same time. This is handy for cutting and pasting between two copies of the notepad, or when running more than one terminal session with the terminal emulator program. That means it is also used for cutting and simply cut the copy and use this one for simply displaying with the messages. That is, each running copy of a program is known as the program instance. That is, we are either using the notepad or when running more than one terminal session with the terminal emulator program. That is, Windows allows to use more than one copy of a program at a same time. That can be used for simply cut and paste between two copies of a notepad or when running more than one terminal session. For example, if I'm using remote login, that is, remote login means I'm available over here, there is a remote host and I have to interact with the remote host, that is my computer at my location, interact with the computer at the different location, that is known as the remote hosting. So Windows programming also provides to execute or run more than one copy of a program at a time. That is and that each running copy of a program is known as the program instance. Suppose five programs or 5 copies of a program are executing at the same time. So 5 copies individually are known as the program instances. So what is a program instance? Simply a copy of the program, a single copy of the program that is executing at the same time, that is known as the program instance. Next point says Windows performs an interesting memory optimization trick. That is, Windows performs an interesting memory optimization trick, or that is, window programming uses an interesting optimization trick. Now, what is this? That is, it shares a single copy of the program code between all running instances. This is the most important point. That is, it is also possible in the Windows to execute or run more than one copies of the program. That can be done, or for better memory utilization, memory optimization, it shares a single copy of the program code. That is, there is only single program. That is, there is only single program, and that program code is shared by each and every running copy of the program. That is, that can be shared by every program instance. For example, if you get 3 instances of notepad running, that is, at the same time 3 notepads are running at the same time. 3 instance means 3 copies of the notepad are running. There will only be one copy of notepad code in memory. That is, you are displaying that you show that 3 program or 3 notepad codes are running at the same time. But in general, in actuality, there is only one notepad code that is available in the memory that can be shared by every window of the notepad. All 3 instances share the same code. As I told you, but will have separate memory areas to hold the text being edited. This is the most important line. That is, there are three copies or there are three instances of the notepad running. There will be only one copy of the notepad code in memory. All the three instances share the same code but will have separate memory area to hold the text being edited. The difference between handling of the code and the data is logical, as each instance of notepad might edit a different file. That is the difference or what is the difference between handle a code and the data is logical. That is, there are different data, there are different logic that is used for handling the data for each and every notepad. So in simple terms, it is using the different memory, and that there is one notepad code that is shared by each and every notepad window. The program logic to edit the file is the same for every instance. That is the logic that is used to edit the file that is common for each and every application, for each and every instance of the notepad. So there is no reason why a single copy of the notepad cannot be shared. So there is only one single copy of the notepad that can be shared by all the program instances. That is the next, or this is the part. So that's all for this chapter. Chapter number 17 is also finished, but we have left with various practical approaches. Now let's see the summary, or first of all let's take a break, then come back and let's see the summary, and then move to the practical approach. So let's take a break for 10 minutes, then come back starting with the summary, and then move to the practical approach. So let's take a break. Let's start with the session. So come back from the break. No, Joseph, break is over. So right now come back from the break and start with the session. So before break we have covered, or we have finished with chapter number 17. Now let's continue with this. Let's take a summary what we have covered in this chapter, that is chapter number 17, that is see under the windows. So let's take a summary. The first point says a message box can be displayed by calling the message box API function. So this is the first point that is known, that whenever we use the Windows, or whenever we use the Windows programming, whenever we want to create the message box, that can be displayed by using the message box API function. So this is the message box API function that is used to display, or that is used to display the message box on the screen. Next point says message boxes are often used to ascertain the flow of the program. That is, message box are generally used, or often used, or mostly used to ascertain, or to or to maintain the flow, or to justify, or to rotate the flow of the program. That is how the program will be flowed or what is the flow of the program, how it will be executing. That can be determined by the message boxes, right? Next point says appearance of a message box can be customized. So we can customize the appearance of a message box as per my requirement, as per your requirement, as per the user requirement. So it is in the hand of the user that the appearance of a message box can be customized. Next point says the create window API function creates the window in memory. So create window button is used, or create window function API function is used, that creates the window in the memory. That is used to create the window in the memory. That is the next D point. Next, the window that is created in memory is displayed using the show window API function. So this is the next part, or the window that is created in the memory, or the window that have created in the memory is displayed by using the show window function. So one is create window function that is used to create the memory, create the window in the memory. One is show window function that is used to display the window on the screen. Next, F point says a window class specifies various properties of the window that we are creating. That is, Window class is used or specifies what are the various properties that is available while that we have created the window. That is, uh, we have created the window, and the window class specifies the property of that window. What are the properties, what are the attributes, what are the dimensions that is available in the window. Next point says the header file, that is the window.h, contains declaration of several macros in Windows programming. That is, window.h is used. This is the header file that contains various declaration of various macros, several macros that is used in Windows programming. That is the header file, that is the window.h. Next point says when the user click in the window, that is whenever the user click on the button or moves using mouse pointers on the window, messages are generated and posted in the application message queue. So whatever the operation, whatever the input, whatever the input that is given by the user, either with the either click with in a window, either move using the mouse pointer on the window, messages are generated and posted in an application message queue. Next point says a message contains the message ID and its additional information about the message. We have also covered that a message is the body of the message contains, or it is either contains a message ID and the additional information about the message. Message ID is a unique ID for each message and also contains the additional information like what is the message, how it will be used, what is the coverage area of the message. Next point says the get message and the dispatch message function looks or loop breaks when get message encounters the WM quit message. That is, two functions are used. One is get message, one is dispatch message. That breaks the loop whenever whenever encounters or whenever a WM quit message encounters in the loop. Right. Next point, last point says if we do not handle a message received by our application, then that is if the on destroy function is not used, that is using the switch case, then the default version is using the def window pro. That is a def default window procedure function is called to the default processing. So these are the various points that we have covered in this chapter. Now there is an exercise. Message box is an API function, true or false. This is the first point. This is known as message box API function. So this answer is true. Next point says calling the message box function displays the specified string in a console window. That is the next point. These are the various true false. The create function creates and displays the window on the screen. This is answer is false. Why? Because this is only used to create a window, not to display the window on the screen. Now the next point is show window that can display only the maximized window on the screen. Windows classes are similar to classes in C++. So these are the various true false questions. So these are the various true false question, and the next point is answer the following. This is a theoretical question. Run any window based program and see whether you can identify all the elements of the application window. Explain the need of register class X function. So these are the various theoretical question. What is the difference between get message and the dispatch message? That is, in get message it is used for creating or getting the message, or for creating and displaying the messages, and dispatch message is used for dealing with the or communicating with the messages. Right. And next, these are the various examples, different combinations. Try with various styles. So that's all for chapter number 17. That is the ending up of the chapter number 17. Yeah, this is the ending up. Now the next chapter is graphics under window, that I am going to start in the next class. But now let's move to the practical approach. Now let's move to the practical approach. In yesterday's class, we have covered about the, or we have started with the while loop practical approach. That is, what is the usage of while loop and how we are using the while loop. So let's continue with this that topic only. That is a while loop. We have covered about the factorial program. That is how to find the factorial of a number using the while loop, using the for loop, and any loop for finding the factorial of a number. As well as we have covered a simple example, that is what is the usage of while loop. Now let's continue with the topic, or let's continue with the program, that we have entered a number through the keyboard and we have to find the sum of the digits. Suppose we have entered, or I have entered 1 2 3 4, and program, or the output of the program is 1 plus 2 plus 3 plus 4. That is whatever the number I am given, so I have to add all the digits together. That is 1 plus 2 plus 3 plus 4. That is the main, or this is the main example, or this is a program that is used to add all the digits of the number. So I want to write this by using the syntax, by using the comment, that is what is the program, so that your concepts are clear. This is write a program to enter a number and find the sum. From the keyboard, this is also used. Write a program to enter a number and find the sum of the digits. From the keyboard, and find the sum of the digits. So this is the main program. Let's start with the program. Let's start with the header file, that is hash include stdir.h, then hash include conio.h, the same files. Now uses the void main, but instead of void main, right now I'm using int main, right? So that your concepts are clear, that whether return 0 is mandatory or not. Then I've declared one variable, that is n, and k, that is equals to 1, sum, that is also equals to 0. Now uses the clr scr for clearing the screen. Now uses the printf statement for approaching with the number, that is enter the number. Then getting the, or storing in the memory, that is by using the scanf, that is the n. Then uses the while loop for this one. Now check the condition while n is not equals to 0. This will terminate when the n becomes 0. This is the main part of this one. Now uses k equals to n Modulus. This is the modulus. I will explain you what is the usage of modulus. This is known as modulus operators. Now, sum equals to sum plus k. Now, k equals to n divided by 10. This is the divided by. Now, n equals to k. Now, closes the while loop or close the while loop. Then simply printf, that is sum of the digits is percentage d. Percentage d, that is sum. That is, yeah, sum. Now get ch. Now closes this one. If I compile this code, there is a warning. Why? Because the function should return a value. Which function? That is the int function. We have used the int, but we have not used the return 0. It's mandatory to use the return 0 whenever we use the int main. Now there is no warning, there is no error. Success. Now if I compile this code, enter a number. Suppose I have entered 1, 2, 3, 4. The output is 10. Why? Because 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. Right? Now if I compile again and I have given the number 7823, that is 7 plus 8 is 15, 217 plus 3 is 20. Right? So this is the program. Now let's see the dry run of the program, that is what is the output and why this gives this output, what is the main crux. That is a dry run of the program in simple terms. So first of all, two header files are used, that is the stdi.h, that is the standard input output. One is common input output, that is conio.h. Now there is a int main, or either we can use void main, but in this if I'm using int main, so in simply it is using the return 0 at the end. There is a int main. Then there are variable declarations. One variable is n, one is k equals to 1, one is sum equals to 0. Why sum equals to 0? Because the output what I need is stored in the sum variable. So whatever the output variable, that must be, or that it's advisable to declare that variable with the initialization with the 0. Otherwise it takes the garbage value. Then there is a CLR, SCR. Hello? Yeah? Hello? 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 Yeah, any question from anyone? No, no, no. Your voice. Yeah, yeah, sure. Now tell me. You are Larry. Your voice is not audible to me. There is a breaking down of the voice. Yes, yes, yes. Tell me the question. Yes. No, there is no mandation. If I use the void, that means there is no return. Hello. Yeah, I understand your question. Now I will explain you the answers. Okay. Your question is why I'm using the int main, right? The answer is that this is a return type. That is a int is a return type, void is a return type. If I'm using the void main, that means the main function does not return anything. That is, there is no return value. But if I'm using int main, that means there is some return of the integer value. So there are multiple languages like C, C++. In C, it is used void main. But if I'm using C++, in this there is a mandatory condition that we have to use the int main. Why? Because in that C++ there is a return type of every program that is written by the main function only. So that's why I'm using int main. So in simple terms, if I want to return something from the main function, then I'm using int main. Otherwise, I'm using void main. But if I'm using int main, so it's a mandatory condition to use the return 0 at the end of the program. Now understand? Okay. So these are the variable that is declared. So it is advisable to initialize the output variable with the 0, because otherwise it takes the garbage value. Garbage value means any value that is fetches from the or fetched from the memory. Now next line is clear screen, only for clearing the screen. Next is printf, that is getting the number from the user, that is enter the number. That is the next part. In simple terms, it gets the output or input from the user. Then uses the scanf for storing. Hello, 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 Hello. So this program says that is k equals to n modulus 10. That is this modulus operator is used to find out the remainder. Now let's see how to find out the remainder. Suppose user have entered the number as 1 2 3 4, right? Suppose this is an example, that is 1 2 3 4. Suppose user have entered this number, so that means you have to find out the modulus, that is divided by 10, like this one. This is 10, this is 1 2 3 4. So 10 into 1 is 10, this is 23, then 10 into 2 is 20, that is 34, then 10 into 3 is 30, and the remainder is 4, right? So the remainder left is 4. This is what I need. So here at the first part the k value is 4, right? Now uses sum equals to sum plus k, that is sum is denoted with the sum equals to sum plus k. Now at the beginning sum has a value 0, so it is 0 plus k has a value 4, so this is 0 plus 4 is 4, that will stored in the sum. Now uses the n divided by 0. The first one is your modulus operator. Now this is divided by, that means divide by 10. Now whenever 1 2 3 4 is divided by 10, that gives the value as a 1 2 3. Why? Because like this one, when this is divided by 10, this will give the value as a 123.4, right? But we are using, or we have declared the k as an integer, so it is using only 123 not point, because it will not execute, or it will not take in the decimal point. So the output is, or the value that is stored in the k right now is 123. This is 123, right? So this is in k it will store. Now initialize the value of k into the n, that is passes the value of k into the n. So now n value becomes 1 2 3, right? Now again check the condition. 1 2 3 4 is 1 2 3 is not equals to 0. Condition is true. Then go to this one. Now find out the 1 2 3 modulus 10. So now it's a time to find out 1 2 3 modulus 10. So this is 1 2, this is 120, and the output is 3 only, right? So the remainder is 3. Right now remainder is 3, so k has a value 3. Now uses this one. Sum has a value 4. This is 4 plus this is 3. 4 plus 3 is 7. So sum has a value 7 right now, right? Now uses k equals to n by 10 and divided by 10. So now this is 123 divided by 10. That becomes 12.3. So this has a value 12. Why? Because it is an integer. It does not take the decimal value. Right? It does not take the decimal value. So this becomes 12. That is k has a value 12. Now 12 will be stored in the n. Now again check the condition. 12 is not equals to 0. Condition is true. Then go to this one. That is 12 modulus 10. Find out the 12 modulus 10. That is 2. Right? I have to calculate 10 modulus 2. That is 10 is, or 12 is divided by 10. That is 10 is divided by 10. That is a 2. Now this is n modulus 10, right? So now this sum has a value 7, because 4 plus 3 is 7. Now 7 plus This is now k value as a 2. 7 plus 2 is 9. Right. Now again go for this one. Now n has a value 12 because this is modulus. This is n modulus 2. No. K has a value n has a value 2. N has a value 2 right now. So n has a value right now 2. So whenever 2 is divided by 10, so 12 is divided by 10, that gives the value 1. So this becomes 1. Again check for the condition. 1 is not equals to 0. Again 1 is divided by 10, that becomes 1. So this is 9 plus 1 is 10. So this is 10. Again check the condition. This is not true. So print the output as a 10. So this is the output. That's why if I'm executing this program, if I give 1, 2, 3, 4, that gives the output 10. Why? Because first of all, it is getting the output as a 4, then 3, that is 7, then 2, that is 9, then 1, that is 10. And at last prints the output with the help of the sum function, with the help of the sum, with the help of the sum variable, that is sum. Then get ch for printing the output. Now this program is clear to all of you. My question is to all of you, this program is clear to all of you? Okay, thanks. Okay, thanks. So let's stop over here only. In the next class, I'm going to continue with the same module, that is a procedure programming module, and I have to cover this topic, that is chapter number 18, that is graphics under the Windows, that is how to use the graphics under the Windows. So let's stop over here only, and let's move, or in the next class I'm going to start with chapter number 18. So thanks a lot everyone. Bye bye.